we go. All right, I'm recording. Okay. All right. So what I'm going to do now is I'm going to move on to the next section, because I think if I remember correctly, we did finish piece 6. Okay, so what I want to do now is move on to this section, which is 1.1. Okay. Now, in this section, what we're going to do is we're going to start looking at equations, okay? And basically, with these equations, we're going to learn vocabulary associated with them. Okay, that's what we're going to learn. We're also going to learn about linear equations in particular, okay? We're also going to learn about linear equations in particular. And not only that, we're also going to learn how to solve these linear equations, okay? So basically we're going to learn about equations in general. We're also going to learn about linear equations. That's a special kind of equation that we're going to see how to solve. They're actually pretty easy to solve. They're not terrible. And not only that, we're also going to see how to solve linear equations in one variable. So again, we're going to see how to solve those. Let me just, hold on a second. I did do square roots last time, right? Can someone answer me?
Yeah, you did.
Yeah.
I don't know. I'm just, okay. I just want to be sure. Okay. And I did finish it last time, right?
Yeah.
Okay. Just wanted to be sure. Okay, but now I want to move on to this. So, okay. Just had to ask. Okay, so anyway, we're going to learn about equations. So, math is one of those things where, like, you might not expect to see vocabulary at first, but there is actually a lot of academic vocabulary associated with mathematics. So here's some vocabulary. For instance, we have this notion of a term. You actually have seen these before, namely in algebra. A term is really nothing more than just a number, okay, or a constant or a variable or a product of these things. So we actually have seen these before. I mean, when we looked at polynomials, for instance, like a single term of a polynomial is a term, as you can probably guess from what I said. So for instance, you can have things like, 5x, x alone, 12, and that's basically what a term is. Okay, it's kind of like the little, how do I say this, like little, I guess, building blocks, if you want, towards, what we're going to see, namely expressions and equations. But that's what a term is by definition. And from terms, you can come up with what are called algebraic expressions. They simply are called expressions, but they're really algebraic expressions. And really, that's just a meaningful combination of them with the operations of arithmetic. And what I mean by that is, you can add them, you can multiply them, subtract them, that kind of thing. A term alone is actually an expression. So these are actually expressions as well. But you can get more than that. You can combine these. For instance, you can get something like 2xy plus 1. That's an expression. X minus 5 is an expression. A polynomial itself is an expression. You're taking a bunch of terms and you're adding them together. Okay? That's what a polynomial is. Okay, so we have terms, we have expressions. What do we get next? We get equations, the fun stuff. An equation, what is that? Well, that's when you basically have one expression equal to another. That's really what an equation is. Now, in particular, you can have equations in one variable. That's where at least one of the expressions, maybe both, for all we know, but at least one of them has to have a variable. And you can only have one variable, hence the name of the term, equation in one variable. So, for instance, if our variable is x, then at most then you can only have x in one or both expressions. You're not going to have something like 2xy, for instance. So that's what an equation is. Now, equation being a statement, that means it can be true or false. You can have an equation that's false. I think we'll see some in a second. Like here, like this one, for instance. This is technically an equation. 1 and 2 are terms. But this equation is false, though. We know 1 is not equal to 2. It's not the same thing. So because of that, this is a false equation. So equations could be true or false. And when you have expressions in an equation, there's this notion of domain, the domain of the variable. Namely, what is the domain of the variable? Well, that's the collection of all numbers for which both sides of the equation are defined. So it's, again, the collection. I have the word set here, but it's really, you can think of a set as a collection. It's a collection of all numbers for which both sides of the equation are defined. So for instance, if you went back to 1 equals 2, the domain of this would be all numbers, because 1 and 2 are both defined no matter what your input is. Or as another case here, right, 19 is defined for every real number, and 7x plus 1, that exists no matter what x is. No matter what x is, 7x plus 1 is defined for every number. So that's why the domain variable x here is all real numbers. Okay, well, domain of the variable sounds like that doesn't tell us much, but what about this equation? Here, 2 is defined no matter what x is, right? There's no restriction on x. However, here there is. We know you cannot divide by 0. In math, that's a big no-no. So because of that, the right side's only defined for when x is not 1. So the domain here, the domain of the variable, is all x except 1, or equivalently, all x such that x is not 1. Now, there is a fancy way to write this in set theory notation. The book does do that, but I'm not going to cover that. So if I were to ask you for the domain of a variable, and I gave you an equation like this, in words, if you wrote something like this, that'd be fine. I'm not going to get too fancy or crazy, that is, with the set theory stuff the book does. I personally think it's doing a lot more than it should, but that's just me. So as another example, what about this equation? Well, as we saw last time with square roots, right? You can only take the square root of a number that's greater than or equal to 0. In this class, you can't take the square root of a negative number. You can't, right? The square root of a negative number is not defined. On the left side here, x here could be any number you want. In this expression here, right, x could be anything. There's no restriction on x. You could take any number you want and add 1 to it. So altogether, the domain here of the variable is all x that are greater than or equal to 0. In other words, all x such that x is non-negative. Okay. I mean, this notation will actually get to, I think later on, not today, but we'll get to this more in 1.5, which is actually inequalities. But this just means x greater than or equal to 0. That's all. But that's what the domain is. Okay. Because again, since we're not dealing with complex numbers, although I want to try and do that eventually, but since we're not dealing with it at the moment, x here can only be greater than or equal to 0. Okay, let me pause the recording because I have to stop and restart